Hi friends, Mrs. Gradney here to welcome you back. Today in our lesson, we'll be solving multi-step word problems. Let's get started. Throughout our lesson today, we'll be using the problem set, so make sure you have that in front of you. And we'll also be using the RDW process, just like it tells us in the directions, to help us make sense of what the problems are saying. So let's get started. Let's read problem 1 together, and then we'll go back and we'll read it in chunks and we'll draw as we go. Ready? Read. Over the summer, Kate earned $180 each week for 7 weeks. Of that money, she spent $375 on a new computer and $137 on new clothes. How much money did she have left? Now let's go back and let's reread that first chunk. Ready? Read. Over the summer, Kate earned $180 each week for 7 weeks. Okay? Now, can we draw something to represent that part of the story? Yes, we can. What can we draw? Let's draw a tape diagram with 7 equal units to represent the 7 weeks, and each unit with a value of 180. Now, do we know the total value of this tape of all 7 units? No, we don't know the total value yet, so let's label a question mark here at the top to show that we don't yet know the value of all 7 units. Now let's read the next chunk. Ready? Read. Of that money, she spent $375 on a new computer and $137 on new clothes. Okay. Can we draw something to represent that part of the story? Yes, we can. What can we draw? It says of that money. And when it says of that money, it's talking about all of this money represented in this tape. And so she spent some of this money here. So let's draw another tape right underneath this one. That's the same size because they have the same value. And let's show that of this money, she spent $375 on a new computer and $137 on new clothes. Let's read that last chunk. How much money did she have left? Can we draw something? Well, we can definitely add our unknown now to our tape diagram. Where in our tape diagram, what part of it represents the unknown that we're looking for? How much money she had left? Point to it. The unknown, how much money she had left, is represented right here. So let's label this part with a variable. I'm going to use the variable M to stand for money. And now we can see the part that we're looking for. Now let the tape diagram speak to you. What does it tell you about how you might solve? Now pause the video and solve the problem using numbers, write the value of the variable, and be sure to write an answer statement. When you're done, come back and we'll compare our work. Welcome back. Did you find that Kate has $748 left? If you didn't, be sure to pause the video, compare your work to mine, and see if you can find your mistake. Now here, I'm showing one way that you could have solved it, but it's not the only correct way. Here's what I did. First, I found the total amount of money that Kate made over the summer here, and that told me the value of this whole tape. Then I added the amounts that she spent to find the total amount of money that Kate spent. Then I subtracted the amount she spent from the amount she made to get the amount that she had left. Now, we could have also found the total amount of money that Kate made over the summer, and then subtracted the amount that she spent on the computer, and then subtracted the amount of money that she spent on clothes one at a time. That would have been correct as well. Let's move to problem 2 now and read it together. Ready? Read. Sylvia weighed 8 pounds when she was born. By her first birthday, her weight had tripled. By her second birthday, she had gained 12 more pounds. At that time, Sylvia's father weighed 5 times as much as she did. What was Sylvia and her dad's combined weight? Now, pause the video and draw a tape diagram to represent the story. Remember, if you get stuck, ask yourself, what can I draw to represent just that one part of the story? And when you're finished drawing for the whole story, come back and we'll compare our drawings. Welcome back. Here's my drawing. Does yours look similar? Now, let's talk about how this tape diagram represents all the information in the story. Where does this 24 come from? What does it match in the story? Pause the video to talk out your thinking. In the story, we don't see the number 24 written anywhere, but it represents Sylvia's weight once it had tripled. So how much she weighed by her first birthday? 8 times 3. But I did the tripling in my head instead of drawing 8 3 times or drawing 3 units of 8. But if you drew 3 units of 8, that works too. Then this 12 represents how much more she had gained by her second birthday. Together, 24 and 12 represent how much she weighed by her second birthday, and that is 36 pounds. Then we have a tape that represents her father's weight. Her father weighed 5 times as much as she did, so we can see 5 units the same size as Sylvia's. And we're looking for their combined weight, and we can see that represented here with the variable W. Now let the tape diagram speak to you. What does it tell you about how we might solve? Well, there's definitely more than one way to solve. So pause the video here and solve the problem using whatever strategy you'd like. Write the value of the variable and be sure to write an answer statement. When you're done, come back and we'll compare. Welcome back. Hopefully you found Sylvia and her dad's combined weight is 216 pounds. On the screen, you can see one way that you could have solved the problem, but it's not the only correct way. Did you think about it in a similar way or in a different way? Here's how I thought about it. In my tape diagram, I could see that Sylvia's father's weight was 5 units of 36. And then Sylvia's weight was another unit of 36. That's 6 units of 36. So I multiplied 36 times 6 using the standard algorithm. We could have also used the partial products method or an area model. Let's move on to problem 3 now. Let's read the whole thing together. Ready? Read. 3 boxes weighing 128 pounds each and 1 box weighing 254 pounds were loaded onto the back of an empty truck. A crate of apples was then loaded onto the same truck. If the total weight loaded onto the truck was 2,000 pounds, how much did the crate of apples weigh? Now pause the video and draw a tape diagram to represent the story. Remember, if you get stuck, read one chunk at a time and ask yourself what you can draw to represent just that part of the story. When you're finished drawing for the whole story, come on back and we'll discuss. Welcome back. Does your drawing look similar to mine? How does this drawing represent what's happening in the story? Pause the video to talk out your thinking. Well, this part here represents the 3 boxes that each weighed 128 pounds. And this part here represents the box that weighed 254 pounds. And this part here represents the crate of apples, which we don't yet know how much it weighed, but we do know that the value of all of these tapes together is 2,000. So let the tape diagram speak to you. What does it tell you about how you might solve the problem? Of course, there's more than one way to solve it. So pause the video now and solve the problem using whatever strategy you choose. Be sure to write the value of the variable, and don't forget to write an answer statement to answer the question. When you're done, come on back and you can compare your work with mine. Welcome back. Did you find the crate of apples weighed 1,362 pounds? On the screen are two different ways that you may have solved the problem, but of course these aren't the only correct ways you could have solved. Pause the video and analyze these two solution pathways and explain each strategy out loud. Both strategies started by finding how much all of the boxes weighed together. So finding the value of these tapes here. But then to find out how much the crate of apples weighed, they tried different things. In the first strategy, they used the subtraction algorithm, subtracting across zeros. It looks like they thought about 200 tens as 199 tens and 10 ones, and then subtracted. In the second strategy, they counted up from 638 to 2,000 using the arrow way, and then they added together the amount that they counted up. Excellent job today, friends. Today, we solved